The system of equations has a unique solution. Find the solution using Gaussian elimination. The first equation is x plus 2y plus z equals 2. The second equation is 2x minus 3y plus 2z equals 4. The third equation is 4x plus y minus 3z equals 1. The first step is to form an augmented matrix. The coefficients are the first row 1, 2, 1, and the constant on the right of the equal sign is 2. The second equation will give us the row 2, negative 3, 2, 4, and the third equation gives us 4, 1, negative 3, 1. This is an augmented matrix. To be clear, we use the dot dot or a line that separates the left and the right hand side of the equal sign. To use Gaussian elimination to solve the system of equation is to turn this augmented matrix into a row echelon form, where the entries along the diagonals are all 1 and all of the entries below them are 0. So first, we need to turn the entry with number 2 in the second row to 0. And we can do that by performing the row operation. We take row 1, multiply negative 2 and add to row 2. If we take negative 2 and multiply every entry in row 1, we will get negative 2 times 1 is negative 2, negative 2 times 2 is negative 4, negative 2 times 1 is negative 2, and negative 2 times 2 is negative 4. This is 2 times row 1 negative. We then add it to row 2, which is 2, negative 3, 2, 4. This will give us 0, negative 7, 0, and 0. We then obtain an equivalent matrix with the second row being 0, negative 7, 0, 0. And we keep the first and the third row. The first row is 1, 2, 1, 2, and the third row is 4, 1, negative 3, 1. Next, we need to turn the entry with number 4 into 0 in the third row, and we can do that by performing another row operation. This time, we will take row 1, multiply negative 4, and add it to row 3. If we take negative 4 and multiply row 1, we will get negative 4. Negative 4 times 2 is negative 8. Negative 4 times 1 is negative 4. And negative 4 times 2 is negative 8. We then add to row 3, which is 4, 1, negative 3, 1. This will give us 0, negative 7, negative 7, and negative 7. So we obtain an equivalent matrix. We keep the first two rows, 1, 2, 1, 2, 0, negative 7, 0, 0. But the third row is now 0, negative 7, negative 7, negative 7. Next, we will need to turn the leading non-zero entry in the third row, negative 7, to 0. And to do that, we either take one row 2 minus row 3, or we can take negative 1 times row 3 and add it to row 2. If we multiply row 3 by negative 1, we will get 7, 7, 7. Don't forget the 0 in the first entry. The second row is 0, negative 7, 0, 0. And if we add the 2, we'll get 0, 0, 7, 7. And this will be going to the third row in an equivalent matrix. We keep the first two rows, 1, 2, 1, 2. The second row is still 0, negative 7, 0, 0. But the third row is now 0, 0, 7, 7. This is not a row echelon form, not yet. To turn the entries in the diagonal into 1, we will take the second row and divide it by negative 7. and we can also take the third row divided by 7. Technically, we take the second row and multiply negative 1 over 7 and the third row by 1 over 7. We obtain an equivalent matrix. The first row is now 1, 2, 1, 2, which is the same. The second row is now 0, 1, 0, 0, and the third row is 0, 0, 1, 1. This is now a row echelon form. The row echelon form is an equivalent of the triagonal matrix. The third row tells us that 1z equals 1. The second row tells us that this is 0x plus 1y plus 0z equals 0. And the first row tells us that this is 1x plus 2y plus 1z equals 2. Using back substitution with z equals 1 from the third equation or the third row, along with y equals 0, we plug these into the first equation where x plus 2y plus z equals 2. But x is unknown, y is 0, and z is 1. This is x plus 1 equal 2, so x equal 2 minus 1, which is 1. We obtain an ordered triplet with x equals 1, y equals 0, and z equals 1. Since this is the system of equation, we still need to check to see if this is the actual answer. The first equation is x plus 2y plus z, and we see that this is 2, so the first equation checks out. The second given equation is 2 times x, but x is 1, minus 3 times y is 0, plus 2 times z is 1. And this is 2 minus 0 plus 2, or 2 plus 2 is 4. The second equation checked out. The third equation states that 4 times x plus y minus 3 times z. This is 4 minus 3 or 1, so the third equation checks out as well. The solution is therefore 1, 0, 1, or x equals 1, y equals 0, and z equals 1.